In this lesson, we're going to talk about the ambiguous case of sine law. In previous math classes, you've already talked about how to use sine law in order to solve for unknown sides or unknown angles, depending on what kind of information you're given about a triangle. But the information that we're given to use for sine law, what we want to know is, does this situation always define exactly one unique triangle? Okay? What we're focusing on here is using sine law to solve for an angle when we know two side lengths of the triangle and we know the measure of one of the angles opposite those sides. Okay, so we're looking specifically at that situation, and in fact, given that particular information, it doesn't always define one unique triangle. Okay, so we're going to look at an example where you're given a measurement for angle A, and you're also given, let's list this up here actually, you're given the measurement of angle A, and you're given the length of side B. So those are the things that are given in your problem. So here's angle A, so this angle is set. And here is side B, so that side length is set. So we cannot change those two pieces of information. Okay? What we want to know is, if we look at the third piece of given information, because we're going to need one more piece of information here to solve for an unknown angle. If we look at that third piece of information, will there always be exactly one triangle formed? Or, in fact, is it possible to form a triangle at all? Okay, so let's take a look at this. So again, here is the given angle A and given side length B. So those two things are set. We can't change them. Okay. Now, let's say that we want to end up solving for angle B. And angle B is somewhere over here. We don't know how long side C is. Okay. So maybe angle B is here, potentially. Okay. And if angle B is there, then this would be side A. Okay, so let's say that we're given angle A, we're given side length B. Let's say that we're also given side length A in the problem, and we're asked to come up with angle B. Okay. Now, for certain values of A, we're going to have one triangle formed. Okay. However, there might be certain measurements that are given for length A that don't actually form a triangle at all, or could possibly form two triangles. Okay, so we're going to take a close look at those cases. Okay, so the first case we want to look at is the case when side length A is equal to the height of the triangle. Okay, so if side length A is equal to the height, then I can draw side A in here. This will be a right angle, and this gives us angle B as well. So angle B is the 90-degree angle. And if A is equal to the height of that triangle, then I can form exactly one triangle with side length A. If I move that side length anywhere else, I'm not going to form a triangle at all. Okay? So if side A is equal to the height of the triangle, then I know that I'm going to have one triangle formed, and that triangle is actually going to be a right triangle. Because the height of the triangle will be at a 90-degree angle to the base. Okay. In the second case, we're looking at the given side length A is less than the height of the triangle. Okay, so if we draw in the height here, that height is at a 90-degree angle. We don't know where point B is. Point B could be anywhere along this bottom side because we don't know how long side C is either. Okay? That's not part of our given information. But in this case, we're told that side A is less than the height. So if I draw in a side length for A that is less than the height, A might be maybe that long, okay? Or A could be this long, as long as A is less than the height of that triangle. And it doesn't matter where I draw in a length A that is less than the height, I won't actually be able to connect that side length A to side C on the bottom of the triangle here. And so if the side length that's given for A is less than the height that's here, then I'm not going to be able to form a triangle at all. Okay, so for this case where A is less than H, okay, so I can draw in an example side length A. Okay, this is one example where A is less than the height here. I know that there's going to be 0 triangles formed. And what we can observe here is that because A is so short compared to that height that's there, we won't be able to connect side A to side C. Okay, in the third case, we're looking at the given side length A is greater than or equal to side B. So again, here's side B. Okay, it would be opposite to angle B, which is somewhere alongside C here. We don't know exactly where angle B is located yet. Okay, and side A is opposite angle A. We're told is greater than or equal to B. Well, if side A is equal to B, then we would end up with a triangle something like this, where B is equal to A. We'd end up with an isosceles triangle. So we can put that under our observations. So if A is equal to B, then we have an isosceles triangle. Okay. Or it's at least isosceles. It could actually be equilateral as well, depending on the measurement of side length C. But it's at least isosceles. If A is greater than B, then we might have a triangle form something like this, where this is angle B. Okay, so if A is equal to B, we get one triangle that's formed. And if A is greater than B, we also get one triangle that's formed. So we can conclude here that there's one triangle. In this fourth case, we've got side length A, which is given in the problem, is less than side B. So again, this is B, so we know it's less than that length. But A is also greater than the height. Okay, so A is greater than the height. So we could draw in a sample length for A, maybe look something like that. We can't make a triangle like that because side length A right now is going past side C. So we want the end of side A here to connect somewhere with side C. So we could draw in side length A like this and make a triangle here with angle B being located in this spot. Or we could swing that around and we could draw in side A here and put point B here. So here there's actually two different triangles that can be formed if side A is less than the length B but greater than the height. Okay, because we can swing that side length A to the left of the height or to the right of the height and come up with two different triangles. So we're going to get one triangle that looks something like this, where angle B ends up being obtuse. And we're going to get a second triangle that looks something like this, where angle B ends up being an acute angle. Okay, so in this case, if A is greater than the height but less than side length B, we're going to actually end up with two triangles that are possible. Now, if we're using sine law in order to solve for angle B, this means that we're going to have to get two different solutions for angle B, because we have this triangle as a possibility, we're going to have one answer for angle B that is obtuse. And if we have this possible triangle, we're going to have another answer for angle B that is acute. So we will have to look at both possibilities in our solution. Okay. There's two more scenarios that we're going to look at, and these are both for obtuse triangles. So this is for if angle A is a measurement that is greater than 90 degrees. Okay. So if angle A is greater than 90 degrees, we're given angle A here. Again, we're given side length B. Angle B would be somewhere alongside C here. Again, we don't know exactly where it's located unless we look at what side length A looks like. Okay? So see if you can come up with how many triangles each of these two scenarios would have, but we'll talk about these in class as well.